All right, this is lesson 1.6, and we're going to continue to solve equations, but these are not going to be quadratic equations. We're going to branch out and see how the calculator can be useful for solving all kinds of equations. Throughout this course, you're going to be asked to solve equations at different times. Sometimes a particular method will be required, but when it's not, I want you to always have this calculator and the process that you can use to solve equations with it. So I have some general statements here. These are available in your formula packet. All right, I want to talk about these steps and write down just a sample. If you were asked to solve x squared minus 4 equals 0, which is a quadratic equation, you could do it by factoring because it is the difference of squares, and that would be x plus 2 times x minus 2, setting each of those equal to 0. X plus 2 equals 0, or x minus 2 equals 0, which means we get a solution set of -2 or +2. If you were going to do this by using the TI-83 or 84, it says set the equation equal to 0. Well, it already is. Go to your calculator and you're going to use the y equals button. Let me pull the calculator up. The y equals button is right here, and I just touched it and it has turned red. This particular model has colors, but you don't have to have those colors at all. You should have y1, y2, y3, and so on. I think you'll have down to y9 and then possibly one more, a y0. You should have some plots at the top, but don't worry about that right now. All right, so that's the y equals. My cursor is blinking there. It says let y equals one side of the equation, let y equal 0, which is the other side. So I'm going to say that y1 is x squared minus 4, and I'm going to say that y2 is the other side, which is 0. And since I always set them equal to 0, I'm always going to have that y2 is 0. It next says graph and set a window to see the x-intercepts and the n-behaviors. Something that's very helpful, and we may not really be there yet, is to know when you're looking at this relationship, y1 is equal to x squared minus 4, what kind of shape will it have? Quadratic equations, when they turn into quadratic functions, graphable versions, always have the shape of a U. If the x squared's leading term is negative, it's an upside down U. Y equals 0 is a horizontal line along the x-axis. So for this particular problem, I'm going to have a U shape and a horizontal line. So let's go ahead and type those in. So back to the grapher. In the first one, I will type variable x, which is right here. The key has turned red. Squared, it is over here on the left, and it has turned red. Minus and 4. You can see that as I press keys, those have turned red. I can either use the down arrow or I can press enter. If you press enter, it goes to y2. If I had pressed the down arrow key instead, it would have gone, but now I have to press the up to get to y2. Here I will type in 0. I have these two equations in my grapher. It says to set a window so that I can see the shape of both graphs and the end behaviors. So in other words, to see a pretty good picture of that U shape. A standard window is -10 to 10, -10 to 10. Now here's Y min, here's Y max. I'm sorry, X min and X max. X min is the left-hand side, X max is the right-hand side. Y min is the bottom, Y max is the top. So when you're looking at a graph, your X max is the largest X value, your X min is the smallest, your Y min is the bottom, and your Y max is the top. And it's a little bit like photography. You want the graph to be somewhere in the window you're looking at. If you need to see more to the right, you increase X max. If you need to see more down at the bottom, then you make this a bigger negative number. More negative. All right, so let's go back to it. And I have a standard window. That's where I'm going to start. I start quite often with a standard window. And now I'm going to press the button. All of these 4 buttons at the top are the graphing buttons. I'm going to hit graph, and it's going to graph this graph within a standard -10 to 10, -10 to 10. Now mine has come out in color, and that's really nice. Y1, it graphed in blue. Y2, it graphed in red. You don't always see the y equals 0 graph, but if it's turned on, it will be there. Let's go back to our instructions. Graph and set a window to see the x-intercepts, and we did, and the end behaviors, we did. Use second of the calc button and intersect. Let's see what they're talking about. All right, one of the x-intercepts is right here. The other one is right here. I see them. I would like to know exactly what the coordinates are. All of the calculation that you can use is the second of the trace key, which says calc. So if I push the second and then the trace key, that will activate calc. It says, what do you want to calculate? I'm going to choose, I'm going to go down till it's highlighted. I'm going to choose number 5, intersect. What it means is, looking over here, I have a graph that looks a little bit like this. I want to know what are the coordinates of the point of intersection here, and I want to know what are the coordinates of the point of intersection here. It will give me some number, comma, 0, because the y value is 0, and this one will give me some number and the y value there. Oh, I'm so sorry. That will be 0, because I'm looking for what x corresponds to this 0 and what x corresponds to this 0. Those will be the solutions to the equation. So let's go back. I've chosen second calc intersect, press enter. I'm going to get the one on the left first. I'm going to use my left arrow key, and you can see the cursor moving toward that point of intersection. Get close to it. How close? No, just get close. And now press enter 3 times. Enter, enter, enter. On the bottom of the graph, it will say intersection, and it has x is -2, y is 0. So my first one is -2. That's my first intersection. That's my first solution. Let's go back to the graph. To find another intersection, you have to start over. Second of the trace key, which is calc. I call it second calc. You can choose number 5 by just pushing 5 on the keypad. It has chosen it. Now I need to use the right arrow key to move the cursor along the graph till it gets to the other point of intersection. And I'm pretty close there. Hit enter 3 times. The first time you're saying you're on the first graph. The second time you're on the second graph. The third time it prompts you to guess. I've never really understood why, but I'll press enter. And now I have an intersection at 2, 0. So coming back over here to my work, that is 2, 0. And that is my second intersection. That's my second answer. All right, so these are my steps. We're going to do it so many times. I think you're going to be comfortable with it. Let's look at our first problem. Now they want us to do it by factoring, and then we can check it. Well, we don't really have to. Well, I'm sorry. What happened to question number 1? Let me go find it. All right, I'm not sure why it's not printed here, but I'll just copy it down. Question number 1 wants us to use factoring to solve 2x to the 4th minus 50x squared equals 0. Now I can do this by factoring because there's a GCF of 2x squared. That will leave me with x squared and minus 25 equals 0. So I'll keep my 2x squared, and I will factor this difference of squares into x plus 5 and x minus 5. Here, 2x squared is 0. Divide by 2, and I have x squared is 0, so x is 0. But it is what's called a double answer because of the x squared. Then I have x plus 5 is 0, x is negative 5, and I have x minus 5 is 0, so x is 5. The answers that I will see on the grapher will be 0, negative 5, and 5. Some of the things I'm telling you now, we will re-study in another lesson. There is going to be a slight difference in the way a graph looks when one of its x-intercepts is what we call a double. Because it was x squared, that meant x equals 0, x equals 0. This will be an x-intercept, but it will be a point of tangency. And what that means, whoops, there's no T there. What that means is the shape of a 4th degree polynomial function is like a W. All right, so I have an intercept at negative 5, an intercept at 0, and an intercept at positive 5 because those are the solutions. I've already done it by graphing, but I want to learn about doing it. I've done it by factoring. I want to learn about doing it by graphing. The shape is this. So it will come down, go through, turn around, come up. It will not go through because that's a double. It will come back down and then it will go through. This is not exactly what you're going to see on the calculator screen, but this is a simplistic view of it. And I know that you don't already know all these shapes. So this is just an initial lesson on this. All right, let's go to the grapher. I'm going to go to the y equals. I'm going to clear out the first one. And I know that what I'm going to put in there is y1 is equal to 2x to the 4th minus 50x squared. I will have y2 is 0, and I already have that. So in the first one, I have 2, then x raised to the 4th power. Use your right arrow key to get out of there if your calculator indeed made a little upper size, superscript size exponent. And then minus sign, 50 x squared. You can pause this recording anytime you need to make sure you have everything in there. I am still in what's called a standard viewing window, -10 to 10, -10 to 10. We'll see if it's okay, and we will do graph. Now, if I knew absolutely nothing about this shape, this just looks like a vertical line, an upside down V, and a vertical line. But we have discussed that it should look sort of like a W. So down here at the bottom, I need to see much more, which means I'm going to change Y min window. Y min. Now I can just touch it, but typically what you do is move down to it, and I'm going to say -100. I don't know if that's going to be too much or too little. So here comes that side of the W, goes up, touches, comes down, goes back up. I still don't see the bottom. I don't have to see the bottom, but I like to. I like to see the whole graph, or at least the whole general shape. So I will put -200 and see if that will do. Comes down, goes back up, touches, comes back down, goes back up. Well, I still don't see the bottom. I'm being a little bit, I'm doing some things that are unnecessary because actually all I care about are the x-intercepts along the x-axis. But I'm really quite curious, so I'm going to say -400. I got more aggressive with the number. There we go. Now mine is a silly version of it, but it does still look like a W. Along the top you can see that it has drawn the y equals 0. How do I find this point, and this point? Second of the trace, which is calc, number 5. I always start with the leftmost. Now let me show you something. I am on the 4th degree function. I could get there faster if I traveled along the y equals 0. If you click up or down, it toggles between the graphs. So now can you see that I am traveling on the y equals 0? Go over until you're close to it. That looks close. Enter, enter, enter. And the first intersection is -5. I had done it algebraically, so I had gotten it right there. Then I start over. Second, calc, number 5. I want to head to this one. All right, I am on the W shape, so I'll toggle it up, and now I'm on the horizontal line. Okay, I'm there. Enter, enter, enter. I get an intersection at x equals 0. Go back to that picture for a minute. And then I do it one more time. Second, calc, choice number 5. Go over. Because I'm trying to get to this point. Enter, enter, enter. And I got +5. I knew that the 0 was kind of a different kind of intersection because it didn't pass through, and we will study that more later in the course. All right, let's look at our next one. Now it says to solve it by factoring. You would set it equal to 0 and you would end up using grouping, but I'm not going to do that because it's not what I'm trying to teach right now. I'm going to take it and I'm going to take the 49x, move it to the left, and the 98 and move it to the left. So I have x cubed plus 2x squared minus 49x minus 98 is equal to 0. So I set the equation equal to 0. y1 will be x to the third plus 2x squared minus 49x minus 98, and y2 will be 0. I haven't talked to you about shapes of cubic functions, but I will tell you that they tend to be kind of roller coasters. So we will study each of these in more detail later in the course. So I'm just giving you an idea for right now. So let's go to our calculator and type this information in. Go to the y equals. I'm going to press clear. Well, I'm going to lose my calculator. And I'm not sure. Oh, I do know what happened. So sorry. I had a cat visit me while I was working, and he chose to type on my screen. All right. So I have cleared y1, and I will type in, this is x raised to the third power. Now mine made it as a tiny exponent. If yours did too, you need to use the right arrow key to get out of that, plus 2x squared minus 49x minus 98. All right, so I am in this window with this minus 400. I think I will do a zoom 6. Zoom 6 sets you back to the standard -10 to 10, -10 to 10. Now I don't know that I'm going to like this window, but I like to start with this window. Now if you know nothing about this graph, it looks like you got 3 almost vertical lines. But what you really got was a very close-in version of this so that you don't see any curvature to it. So let's go back, and I think we need to see more up here. That would be y max. We need to see more down here. That would be y min. My x's have been okay. So down, down. Don't worry about that x scale. All right, I will go y min, I think I'll go -100. And y max, which is the top, I'll do +100. Hit graph again to see. Now, just so because we're playing with windows, I have a perfect top part of my window. I see the top of the hill. That looks good, but I don't see the bottom of the valley. So if no, I didn't want to do that. Go to window. It is y min that I need further down. So let's go -200. Let's see if that's enough. So that part's fine. Comes down. You know, I'm okay with it. If I really, really want to see it, I could come in and change that y min one more time, say -250. This is giving us an opportunity to play with the window feature a good bit. There we go. Now, although this is a beautiful graph and mine is kind of a cartoon graph, I hope you see that they have similar shapes. All right, I'm going to find this intersection, and this intersection. The y's will all be 0, but the x's will be my solution set. So here we go. Second of the trace key, which is calc. Choose number 5. You can stay on this graph, or you can switch over to being on the y equals 0 graph. I always go all the way and get the left point of intersection first. There we go. Enter, enter, enter. The solution set, the first value, the leftmost value, is -7. Let me go back to the picture. -7. Then I start again. Second, oops, not alpha. Second, calc, number 5. You'll get used to doing that. And I'm on the blue graph, but it doesn't matter. Yours might or might not be colored. Okay, close to it. Enter, enter, enter. The next answer I get is -2. And I don't need that. But I do need this. All right, time out. Sorry, it took me a minute to, actually it crashed and I had to get this back. So pull the grapher back up, and I'm going to do second of the trace, which is calc. Choose number 5 one more time. I think I will hit up so that I travel along the red line. I think it will be a little quicker. And I'm just tapping this button. Enter, enter, enter. And I got +7. If I had solved this algebraically by doing my grouping and all my factoring, I would have gotten -7 and +7 and -2. All right, let's look at number 3. This is a cubic equation, so when I turn it into a function, it will look a little bit like a U, not like a U, like a roller coaster, provided that the leading coefficient is positive. So I'm going to leave it positive. I'm going to bring the 12x over here and the -4 over here. So I'm going to have 3x to the third minus x squared minus 12x. When the 12x moves over here, it becomes negative, plus 4. When the -4 comes over here, it becomes positive, and that will equal 0. So in my y equals, I will have y1 is 3x to the third minus x squared minus 12x plus 4, and I will have y's blob y2 be 0. I am looking for 3 places where it crosses the x-axis. So I will go to y equals first. I will clear this one out, and I will type in 3, letter x. Let me clear that again. All right, got a little problem. All right, so I'm back. I have my 3 variable x raised to the third power. Use the right arrow key to get out of the exponent, minus x squared minus 12x plus 4. And I already have the 0. I'll just leave the window I have. Remember, I have that window from the last one. I don't know if it's a good window or a bad window, but I'll see. I can always go back and hit a standard viewing window. Well, it's not bad, but I think it is a lot further down than I actually need to be. I'm losing a little bit of, it's like if you were taking a picture, you're too far away from the action shot. So if I go to window, my X's are okay. My Y min, I'm only going to do -100. So let's see what it looks like. It's better. If you want it even better, we're still too high. There's too much space at the top and too much space at the bottom. You don't have to work with the window this much, but I am. And remember, top and bottom are always Y's. So I'm just going to put -25, and for Y max, +25. And let's see. There we go. All right. If you wanted to, you could say, well, there's too much space on the left and too much space on the right. So remember, I'm teaching about windows while I'm doing this. So maybe it doesn't need to be all the way out to -10. Maybe I can make it -5. And maybe I can just make it +5. Let's see now. Okay, this is a very nice window now. You can play with the window all you want. And it keeps, at the end, it graphs this one. On some calculators where everything is black, you don't even see that happening. All right, second of the trace, which is calc. Choose number 5 for intersect. I'm going over here first. Enter, enter, enter. My first answer is X is -2. Do second, calc, number 5 again. Head over there. Looks pretty close. Enter, enter, enter. I got 0.33333. Now, MyMathLab does not want that because it says simplified fraction. So I hope that you know that 0.333 and so on is really approximately the fraction 1/3. That is a limitation to using the calculator. And then finally, we'll do second, calc, number 5. Enter, enter, enter. And our final answer is +2. So this may be an issue for us sometimes. Number 4, it asks us to solve a radical equation. I've put all kinds of equations in here. Now, the radical equations tend to either look, I call them branches. They tend to either look like that, where they have a starting point, they branch like that, or they might have a branch going this way. There could be some up-down reflections also, but they are branches. Keep that in mind. All right, now on this one, I still need to get it set equal to 0. So I'm going to have the square root of 10 minus 3x minus an x is equal to 0. All right. I will have y1 is equal to square root of 10 minus 3x minus x, and y2 is 0. Now I'm not sure, ours may have deviated from this shape a good bit, but we'll just see. So let's go to the y equals, and I want to show you, go to y equals, clear that first one, and I want to show you the square root key is the second of the x squared key. So when I do not that, clear it, second of x squared, my calculator actually will type the radicand underneath there. 10 minus 3 times variable x. If yours doesn't, if it looks like this, y1 equals square root open parentheses 10 minus 3x, because it might look like that, you simply close the parentheses, and that's telling the calculator that you are finished with the radical, and then you'll put minus x. Mine looks very much like what I want to type. I need to get out from under the radical, so once again, hit the right arrow key. Now I'm out of the radical, subtract x. All right, I'm going to do a zoom number 6, which gives me a standard window. Okay, well, this actually is a branch, but it is a branch that has been twisted all around. So you can see it has a starting point and it's heading off at a weird angle. It's a branch, but it's a weird branch. There seems to be only one point of intersection. Second, calc, number 5, head to that x-intercept, enter, 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 and I get a single answer. Let me go back to that real quickly. Got rid of it too fast. I believe that the answer is 2. And I don't have any other answers, and that's what I got. So when I said that they were branches, we got a branch with a point, and then it kind of went off like that. Some kind of branch. All right, number 5. I have another radical, and I'm going to take it as the square root of 5x plus 4 under the radical, minus an x to bring that over, add the 4 equals 0. So I will set y1 equal to the square root of 5x plus 4 minus x plus 4, and y2 as 0. And I'm expecting some kind of branch. So here we go. Go to the y equals, clear, and this is second of the x squared, gives you the radical. Type in 5 variable x plus 4. You will either close your parentheses or you will use your right arrow to get out from under the radical. Subtract x, add 4. And I already have my 0. I'm just going to leave it in the standard viewing window and see what I get. All right, there's a different branch. The issue that I have is that this branch is headed down and it's going to intersect the x-axis, but it's outside my viewing window. So what do I need to increase? Window. I need to increase x max. The right hand side is x max. So I'll just change it to 20. And now it looks good. Here comes y equals 0. I will do second, calc, number 5. Go toward the point of intersection, which is an x-intercept in this case. In all of these cases, enter, enter, enter. And the answer is 12. All right, Let's do one more with a radical. Here it is, and it is the square root of 2x plus 20. I will bring over the x, it will become minus x. I will bring over the 6, it will become negative 6, equal to 0. That means that I'll have y1 is the square root of 2x plus 20 minus an x minus a 6, and I will have y2 is equal to 0, and I'll be looking for some kind of branch. So to the y equals, clear. To get my square root, I have second of the x squared key, 2 variable x plus 20. Either close parentheses or use the right arrow key, minus x minus 6, and something happened. I will do second, insert, and insert my minus sign, and it did not go well. So I'm going to simply go back and delete, 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 and try it again. Subtract x, subtract 6. And it looks like I have a 0 in front of this. I'm going to try to go back. I don't know how I managed that. I'm sitting too far. Okay, I'm on that 0. I'm going to hit delete. All right, that took some work. I'm not sure what was going on, but hopefully that's right. And I'm just going to see what I see. All right, you could do a zoom. Oh, let it finish. A zoom 6, which gets me back to that standard viewing window. I didn't have to do that, but I could, and I did. Second of the trace key, which is calc, number 5. The point of intersection is back here. Enter, enter, enter. The point of intersection appears to be -2, and that is my solution set. All right, because I wanted us to experience a variety of things, the next problem I've chosen is an absolute value equation. The symbols for absolute value are vertical bars. Usually, all right, there's stuff in there. Usually the graph of an absolute value is some kind of a V. It could be an upside down V, or right side up V, but it should be a V. And I will be showing you on the graphing calculator, we don't get these vertical bars. We instead get an abbreviation ABS for absolute value, and you will put whatever you need to in there. So whatever is between the bars is between the parentheses after ABS. Originally, my problem is 5, absolute value bar, 2x minus 5, close absolute value bar. I need to bring the 15 over. Minus 15 is equal to 0. When I type this into my into the calculator, y1 will be 5 ABS, open parentheses, 2x minus 5, close parentheses, minus 15. And yes, I'm going to show you where to get this. And y2 will be 0. All right, so let's go to the grapher. Go to y equals and clear. All right, we start out with 5. Now I need ABS. There are several places within this calculator you can get ABS. Here's the quickest. The second function of the 0 key says catalog. Second, 0. And it just so happens ABS, because it starts with an AB, is the very first entry in the catalog, and that's the quickest way to get it. Press enter. I'm sorry, I had forgotten, mine actually puts absolute value bars. The older operating systems do not. So some of you may have exactly what I wrote. Some of you may get this. Inside the absolute value is 2, variable x, subtract 5. If you have the ABS, you will close parentheses. If you have the absolute value bars, you will simply hop to the right. And it is minus 15. And that didn't, I don't know why it's doing some weird things. Let me go back. Minus 15. So my graphing emulator is being a little bit weird. So I do have it. Now keep in mind, I have absolute value bars, which I think could be mistaken for ones. The ABS will not be mistaken for ones, but you'll have one or the other. And I'm going to do a zoom 6. That's a nice starting window. And I do see the V. I don't see the very bottom of the V. That means that I could change Y min. So if I go to Window, and I go to Y min, which is set right now at -10, and change it to say -20, that's fine. If you want to shrink your horizontal window a little bit, you can, but I don't see any real need to. Let's find this x-intercept, and after we get it written down, we'll find this x-intercept. So second, calc, choice 5. Now if you don't see your cursor, hit the up or down arrow to get it on the x-axis and you will see it. Because sometimes it'll be out of view. Enter, enter, enter. My first answer is x equals 1. That's the first solution. I don't have to do any algebra. I'm doing a graphical solution. Second, calc, number 5. And I think I'll hit my toggle switch. Remember, up and down, toggle it between the graphs. I like many times to travel on the x-axis. Enter, enter, enter. My second solution is 4. I did not do any of the algebra involved in solving an absolute value equation. Let's look at number 8. All right, this one looks like it may be a challenge to type in. I have 2. Absolute value 6 minus, I'm going to call this 3x over 2, close absolute value, plus 8 and minus 20 equals 0. I'm not even cleaning this up. You could, but I'm not going to. So I have y1 is equal to 2. Most of you will have ABS, open parentheses, 6 minus 3x divided by 2, close absolute value, plus 8 minus 20, and y2 will be 0. Mine will actually have the absolute value bars. So here we go. Y equals clear, and it's frozen up again. Let me see if I can figure that out. Alright, I'm not sure why it's being contrary, but I have 2 second catalog, choose ABS by pressing enter, 6 minus 3x divided by 2. I'm going to get out of the absolute values. I hop out, and for some reason my calculator is wanting to put in some zeros. Let me see if I can get it fixed. Alright, so I have 6 minus 3x divided by 2. Then I have a plus sign, 8, and a minus 20. And I just was lazy. Positive 8, negative 20. I could have a negative 12 there, but I didn't. Alright, I don't remember what window it is, but we'll see if I like it. We'll see if you like it. I think it's going to work just fine. So, second, calc, number 5, and it's sitting there. I'm glad to have that. Enter, enter, enter. Maybe 0 is an answer. It is. So I will go to my work. I have just figured out what's going on. It's making pressure on a keyboard. All right. So I have 0. Let's see what the other one is. Second, calc, number 5. And I'm going to do the toggle, switch it over to the red graph. Enter, enter, enter. And that is 8. So I had 2 x-intercepts. I get 2 solutions. All right, I think we have one more problem. And remember, this was used as a lesson to get you more comfortable with the graphing calculator. We'll be using it throughout our course. All right, I have the absolute value of x plus 7, close absolute value, plus 6, plus 7 minus 6 equals 0. Now, if you want to simplify 7 minus 6 and put 1, you can, or you can just be lazy and type it in exactly as you see it. y1 is ABS, open parentheses, x plus 7, close, plus 7 minus 6, and y2 is 0. All right, let's type it in. All right, I have, to get ABS is second of the 0 key, which gets me into catalog. I press enter to choose ABS, or the bars, and I have variable x plus 7, and I need to go back, use my right arrow to hop out of there, or you close parentheses, plus 7 minus 6, because I was too lazy to actually write 7 minus 6 is 1. So graph. Well, I see the V shape, but I can't really tell what's going on. I'm going to get rid of some of this space at the bottom. So I'm going to bring Y min up, and I'm going to bring X max in. So I don't need to see all the way out to 10. I'll just go to 5. And I don't need to see all the way to negative 20. I think I'll go negative 15. Oh, that's interesting. Does the graph ever cross the x-axis? The answer is no. If you have no x-intercepts, then you have no real solutions. All right, so this was a good practice on some third degree and fourth degree polynomial equations. We did one quadratic to start it with, we did radicals, and we did absolute values. So remember that there are notes very much like this in your packet of information in your formulas, and this is to find solving an equation, or it could be called just to find x-intercepts. All right, practice with your grapher.